Solving absolute value equations with quadratic expressions in them is done in the same way that we solve absolute value equations with linear expressions in them. We're going to take the absolute value and we're going to divide it up into two cases. So the first case is where the absolute value is positive. So we have x squared plus 6x and then equals 7. So we solve this by moving everything to one side, so all the terms, and we can see that we can factor this. So we have x plus 7 times x minus 1, and that equals 0. So x equals negative 7 and 1. And then don't forget, always check. So we're going to check by plugging negative 7 into the expression. And that will be all squared plus 6 times negative 7. And all of this will be in absolute values. And see if that equals 7. So we have 49 minus 42. And yes, we have absolute 7 equals 7, so 7 equals 7. So that one works. Okay, let's do the same thing with positive 1. So 1 squared plus 6 times 1 equals 7. And yes, we have 1 plus 6 inside. So that's the absolute value of 7 equals 7. So yes, 7 equals 7. All right, so the second case is where we're going to take the negative of the absolute value. So we have negative, and then x squared plus 6x, close our bracket, and then that equals 7. So I'm actually going to divide both sides by the negative 1 so that I can move the negative value to the right side. So I have negative 7. Move all the terms to my my left side. And I can see for this one I can't factor. So I'm going to use the quadratic formula. So I have negative 6 plus or minus square root, and my b, again, is 6 squared minus 4 times 1, and then times 7, which is c, all over 2 times 1. So simplifying, I get negative 6 plus or minus, and then 6 squared minus, so it's 36 minus 28, and that's going to be 8 inside, all over 2. And we can simplify this to be negative 6 plus or minus 2 root 2, so we can simplify the radical, over 2. And now since we see that all three of these values are divisible by 2, we're going to reduce this to be negative 3 plus or minus root 2. Now I'm not going to show you an algebraic check, but what you can do is then take both of these values here, negative 3 plus root 2, plug it into x squared plus 6x, and then see if that equals 7. And then also do the same with negative 3 minus root 2, and then see if the left side also equals 7. And when I do the check, if you do the check properly with your calculator, you will find that it does work. So you actually have 4 solutions for this absolute value equation. All right, let's take a look at another one. So you can see something that's a little bit different. So again, we're going to take the positive absolute value. So we have x minus 5 equals x squared minus 8x plus 15. Let's move all the terms to one side. So we have x squared, and then we have minus 9x. Adding the 5, we have plus 20. We can see that this can factor, so this will be factored to x minus 5 and x minus 4. So x equals 5 and 4. So let's do the check again. So we're going to plug in 5 wherever we see x. On the left side, we get 0. On the right side, we get 5 squared, which is 25 minus 40. So it's negative 15, and then plus 15. This side also equals 0. So yes, 5 does work, so that's good. Let's check 4. So we have 4 minus 5 equals 4 squared minus 8 times 4 and plus 15. So on the left, I have absolute value of negative 1, which equals 1. And then on the right side, I have 16 minus 32 plus 15. So 60 minus 30 is negative 16, plus 15 is then negative 1. So actually, this one does not work. So 1 does not equal -1. So my only solution is the +5, and the 4 is extraneous. All right, so let's go to the negative absolute value. So we take negative, and then in brackets, we're going to put x minus 5 equals x squared minus 8x plus 15. Okay, and let's distribute the negative to get negative x plus 5, and then rewrite my right side. Move all the terms to one side, x squared minus 7x plus 10, and luckily we can factor this again. So we have x minus 5 and x minus 2. So x equals 5 and 2. So we actually checked 5 already, so we just need to check 2. So an x value of 2, we get 2 minus 5 equals 2 squared minus 8 times 2 plus 15. So we get absolute value of -3 equals +3. And then on the right side, we get 4 minus 16 plus 15. So 4 minus 16 is -12, plus 15 is 3. So yes, that does work. So altogether, we have our solutions of x. So x is equal to 5 and 2, but not 4 because remember, it was extraneous. What I want to show you next is how to use absolute values to solve problems and how to write them in equations as well. So for example, your supervisor allows you to clock in for your 8 a.m. shift up to 15 minutes before and up to 15 minutes after. So write an absolute value equation that can be used to find the acceptable limits for your clock-in times. Now, it's probably pretty obvious what the times are, but what I want to show you is how do you set this up using an absolute value equation. So what we do know is that the distance from the max and min time to 8 a.m. is 15 minutes. Now I can't really add 15 minutes to the time, so I'm going to use decimal time. So I'm going to put 0.25 minutes. Okay. So if I draw a graph, it would look something like this. Okay. So this is 8 a.m. I'll put that in the middle. And I notice that the distance in either direction from 8 a.m., I want that to be 0.25 minutes. Okay. So what I'm trying to do is to figure out what these two times are, which I kind of know already, right, intuitively. So therefore, I know that the distance from this minimum time and the distance from the maximum time should always equal 0.25. So this distance here, this arrow that I have, this double-headed arrow, can be represented by t minus 8. And this is also t minus 8. Now, I don't care whether the time is negative or positive, so I'm going to place this expression in absolute values. And this distance from the time to 8 is going to equal 0.25. All right, now that I actually do know what the time is, let's check to see if this actually works. So if I solve this as a positive absolute, I get t minus 8 equals 0.25. So t is equal to 8.25 hour, or this actually is going to be 8:15 a.m. If I take the negative time, if I take the negative absolute value, this will be negative bracket t minus 8 equals 0.25. And I'm going to divide both sides by the negative, so I get negative 0.25 on my right. Add the 8, and I get 7.75 hours. Or, in time, this would be 7:45. Okay, so this does work because I know that 15 minutes before 8 o'clock, it is 7:45, and then 15 minutes after 8 o'clock, it is 8:15. So an absolute value expression that can represent the situation would be the absolute value of t minus 8, which equals 0.25.